Hi everyone, welcome back. Hope you're all safe and well. This is video 3 of our hydrocarbon series, and today we're following on from alkanes. I'm going to be looking at alkenes. So before we jump into alkenes, we're going to review alkanes first. So here we have ethane, which is a 2-carbon alkane with 6 hydrogens surrounding it. So that'd be C2H6. And focusing particularly on the type of covalent bonding within this molecule, we'll see that there's a single bond going from the carbon to the hydrogen, which is what you would expect because hydrogen can only form one bond. So you would expect hydrogen to form single bonds with any atom. But looking at the carbon atom, we know carbon can make 4 bonds. But in this alkane, it's only got 1 bond going from the carbon to the other carbon atom. So in alkanes, this is a defining factor, that is, they only form single bonds between the carbon atoms. So they form single carbon to carbon bonds. This is a really easy way to recognise alkanes, is to look at all the carbons and see if there's a single bond there. If it is, it's an alkane. And what this means is that the carbon atom has made 4 bonds to 4 different atoms, 4 unique atoms. It's unable to make any more new bonds, so we would describe alkanes as being saturated. They can't form any more bonds, they're completely full, so we describe them as being saturated. Okay? So moving on to alkenes now, what makes this particular homologous series unique is that they contain a carbon to carbon double bond. So if that double bond wasn't there, you would have seen carbon had only made 3 bonds. We know it makes 4, so we've got that double bond in there. So there's a key factor, a defining factor for alkenes, is they contain a carbon to carbon double bond. What this means is that alkenes are actually able to form more bonds with a new atom in a reaction, let's say. As the double bond breaks, and then this frees up space in the molecule to form new bonds. Specifically for this carbon here to form a new bond in this space, and this carbon here to form a new bond in this space here. So by breaking that double bond into a single bond, we free up the space for these 2 carbon atoms to make a new bond each, so making 2 bonds in total. So having the ability to form new bonds means we're going to describe it as being unsaturated. So alkanes are saturated, alkenes are unsaturated. So with a bit of video editing magic, we're now going to cut over to a table of alkenes, and we're going to look at the molecular formula, the names, and the structural formula of alkenes, okay? So for this section of the video, we want to have page 9 of our National Fire Data booklet open. We want to look at this table here on the right hand side. It contains the melting and boiling point of a few alkenes: ethene, propene, butanene, pentanene, hexanene. Don't worry too much about what the 1 means in here. We'll come to that in a later video on isomers. If you've done the assignments already from Teams, you'll have a wee bit of an idea about what that 1 means. If you don't worry about it. Want to compare this table here to the table on the left hand side. This is the table of alkanes and their melting points and boiling points. We'll notice that it starts with methane and works its way down to octane, going from a 1 carbon molecule to an 8 carbon molecule. Looking back at the table of alkenes, it starts with ethene, which is, we know eth means 2 carbons. Why is there no methane in this table? So we'll give a few seconds to think about that. If you need to pause the video, you can take a few seconds, that's fine. I'll give you a few seconds. Why is there no methane in this table? So the reason there's no methane is because an alkene needs at least 2 carbons to form the double bond. If you've only got 1 carbon, there's not a neighbouring carbon atom to form the double bond with. So you need at least 2 carbons, hence why ethene is the first molecule in the homologous series. There is no methane. So let's have a look at this table now. Work our way down the first few alkenes, have a look at the number of carbon atoms, the name, the molecular formula and the structural formula, and hopefully we should be able to deduce some sort of general formula. So, number of carbons, let's start with 2 because that's our smallest molecule. Name, as we see from the table, that's going to be ethene. Eth meaning 2 carbons, ene meaning contains a double bond. So, with our alkanes, we doubled the number of carbons and we added 2 to get the number of hydrogens. However, because we have a double bond between the carbons, we've actually got 2 fewer hydrogens in the alkene compared to the related alkane. So let's draw 2 carbons over here. And 4 hydrogens. You'll notice that the carbon has formed 4 bonds, the hydrogen has formed 1 bond, so this is the structural formula. Let's go back to a molecular formula. I've now got 2H4, C2H4. Let's move on to propene now, which is 3 carbons. Prop meaning 3, ene meaning contains a double bond. So let's do a full structural formula first. Now here's where you need to be careful. You need to make sure each carbon atom has 4 bonds. So the first carbon atom here has a hydrogen coming off the end, hydrogen coming down. It doesn't matter where you put the hydrogens, it's the number of hydrogens that matter. The reason there's 2 hydrogens is because carbon has already made 2 bonds. 2 plus 2 is 4. This carbon here in the middle had already formed a double bond on one side and a single bond on the other. That's 3, which means we need an extra hydrogen to get to 4. This last carbon had made 1 bond, so I've added the other hydrogen in, which means it's made 2, but we still need another 2 hydrogens to get to 4. Now this molecule is completely stable because it's got every atom with its full outer shell. So now C3H6. Then finally let's do butene. Again, we're not going to worry too much about what that 1 means, 1A, we're just going to call it butene for the time being. Okay, so 4 carbon chain now. We're in that space here. Double bond here. Now let's make sure the number of hydrogens we add is correct. This carbon's made 3 bonds, which means we need another hydrogen. This carbon's made 3 bonds, so we need another hydrogen. This carbon here has made 2 bonds, so we need 2 other hydrogens. This carbon here has made 2 bonds, so we need 2 other hydrogens. So now every carbon has made 4 bonds and every hydrogen has made 1 bond. So that would be C4H8. Okay. Now, last thing we're going to look at is the general formula for the alkenes. Pretty straightforward, this one, forms quite a nice pattern. For the number of carbons you have, you've got double the number of hydrogens. So we write that as C for the number of carbons, N, H2N. CnH2n. Okay, so thank you for watching. Stay tuned for the next video, which is going to be looking at cycloalkanes. That will be the 4th video in the series. If you've got any questions, please ask on the Microsoft Teams. If you want to look into this further and you haven't done the assignments, I would recommend go on to the Microsoft Teams, looking at the files and making sure you catch up on the assignments. If you've already done the assignments and you've watched this video and you're still unsure, either ask one of us or please look at BBC Bite Size or any of the relevant links that we've sent you. Okay, thank you guys.